Hi guys, this is Karthik Arora. In this video, I'm going to explain you my approach to the problem D, a good string, which is from round 656 div 3. So the problem says that we're given with a string S, S1, S2, so on till Sn, and the length of the string N is a power of 2. Okay, so this the length of this particular string is going to be a power of 2, so N can be written as 2 to the power k, where k is greater than equal to 0. We would like to find out what is the minimum cost to convert this string S into a good string. Okay, and now let's see what a good string means and also the operations that we can do. So the operation that we can perform is that we can choose any ith character of the string and change it to any other character as we want. So I could pick the ith character of S and change it to whatever lowercase character I wanted to. Okay, so I could change it to A, B, C up to Z. Okay, any character, and this will count as one operation. I would like to find the minimum number of operations that I can do. The operation is selecting an index and changing it to some other character, such that minimum operations are required to make this string S into a string that is called an a good string. Now, what is an a good string? I'll discuss the examples later on, but let's first of all check what we mean by an a good string. So here is what an a good string is. Either the string length is 1. If string length is 1 and the only character of the string is A, then it is an a good string. Similarly, b good string would be if string length is 1 and the only character of the string is B, then it is a b good string, something like that. Okay, so if len equals to 1, length of the string is 1 and character equals to some lambda, maybe it is lambda is some lowercase character. So if the only character of the string is lambda and the length is 1, then it will be a lambda good string, and lambda is some lowercase character. Okay, otherwise a good string will be the first half. If the length of the string is greater than 1, that means it's a power of 2 but greater than 1, then in that case a good string will be that the first half of your string has to be an a good string and the second half has to be a b good string, a plus 1. Okay, one character greater than a. So if I was trying to find out a b good string, then the definition would be that first half should be a b good string and the second half should be a c good string. Okay, that's the idea here. Or the other ways for an a good string could be that the second half should be converted to an a good string and the first half should be converted to a b good string. So my string is an a good string if it's of length 1 and the only character of the string is a. It's a good string if the first half of the string is all characters of the first half are a and the second half is a b good string, or the first half is a b good string and all the characters of the second half are equal to a. So if either of these three conditions is true, then my string is known as a good string. I'll just give you one small example what I mean by a e good string. Okay, let's see what I mean by e good strings. So e good string would be that if the length of the string equals to 1 and the only character equals to e, then it will be a e good string. Or first half of my entire string is equal to e, all the characters in the first half are equal to e, and second half all the the second half is a e plus 1 good string. And what is e plus 1? A, B, C, D, E, F. Yeah, so second half has to be a f good string. Similarly, for the or, one more possibility that the first half could be a f good string and all the characters of the second half could be equal to e. So that is the idea here. The solution is going to be very straightforward. The important thing here is the proof. Before we go ahead, let me just take one example so it's clear to you. Also, we would like to find out, given the initial string, what is the minimum number of operations you need to do to build a good string. Okay, so initially we are given b, b, d, c, a, and a, and I want to make this string to an a good string. So here the second half is already a's. I want to see now I would like to find the minimum cost in which I could turn this part to a b good string. Okay, so what is the minimum cost in which I could convert BBDC into a B good string. So here BB is already, the first half of the string is already BB. I would like to find out the minimum cost in which I could convert this string into a C good string, because overall I wanted a B good string. First half is BB, so that's cool. Second half I would like to turn it into a C good string. Now for this string I want to make a C good string. So first half is second half is equal to C. All the letters of the second half are equal to C, and the first half I would like to turn it into a D good string, right? C plus 1, and this is a D good string. So this entire thing was already a good string from beginning, so you need to perform 0 operations. So guys, hopefully the idea of the problem statement is clear. Let's approach the problem now. So you are given the string S. It is of length 2 power k, n equals to 2 power k, and you would like to perform minimum operations to make this S to be a good string. So there are two possibilities. Initially you are given the entire string S from 1 till n, and yeah, that's it. You want to make it a good string. One step later, you can either if this length equals to 1, then you just need to check whether the character is A. If it is, then you need to perform no operations. Otherwise, if the length of the string is 1, that means n equals to 1, and the character is not equal to A, then you can perform one operation and change the character to A. So the base case is pretty clear. If length of the string is 1, then you can easily check if the character is already equal to the required character, then cool. Otherwise, you will change it, and one move will be required to make it a good string or whatever you want to make it if the length is 1. So let's assume that length is not equal to 1. In that case, either you can try to make the first half to be entirely filled with A's and the second half to be a B good string, or you could make the second half to be entirely filled with A's and the first half to be a B good string. So two possibilities. One of them is this, that you make the first half to be entirely filled with A's. So all A's in 1 comma n by 2. In this range you have to change every character to a small a. Okay, if there is any character that is not equal to a small a in the first half, then you have to perform an operation and change it to a small a. Plus, what is the minimum cost to make the remaining string into a B good string? That would be n by 2 plus 1 comma n comma B. Or the other possibility is that you change all characters in range n by 2 plus 1 to n into A's. So you turn the second half into all A's, plus you try to make the first half to be a B good string. Since it is clear that there are just two possibilities, one out of these two possibilities is going to be the correct answer, isn't it? One of these will give you a minimum cost, and that will be your answer. So what you can do is you could simply come up with a recursive function that will evaluate these costs. You have a base case, you have a way to break your original problem into smaller problems. Whatever is the cost in this particular case, let's say C1, and the cost for this thing, let's say C2, whatever is the smaller of C1 and C2 is going to be your answer. And that is all. But what will be the time complexity? That is the interesting thing here. So let's analyze the time complexity. We were using this thing, I comma j comma char, okay, some character from A till Z. Let me say character C or lambda maybe. So lambda has 26 possible valid values, and currently it looks like that for every I there are almost n number of values for j, because ij represents a substring of your original string. But what you'll notice is that your length of the subproblem that you're trying to solve, you will always be solving for a substring of length that is a power of 2. So what you can do is you can represent the same subproblem using the following state. You can represent it as the first index the index from which your substring starts, comma, the length of the string. Okay, so you know that the length of the string is going to be 2 power k. For any sub problem that you're going to solve, the length is going to be 2 power k, because initially it was length 2 power k, and no matter how you break it, you're going to break your original string into half, and those strings into again half. So your length will always become divided by 2, and since original is 2 power k, your length will always stay to be power of 2, right? So you can keep a variable j here, or let's say k, and this tells you what is the length of the string to power raised to the power 2. Okay, so you're basically storing the exponent that will tell you the length of the string. So if the length of the string equals to 1, then k will be equal to 0, because 2 power 0 equal to 1. Similarly, if the length of the string equals to 8, then k here will be equal to 3, and k can be at max 26 or 20 maybe. It depends, like the longest n was given to be somewhere about 10 power 5, I guess. Let's take it to be 10 power 6, then k can be at most 20, right? If n equals to, if the length of your string is nearly 10 power 6, then k can be at most 20 different values. This k will tell you what is the length of the substring you're solving for. I tells you the index from where your substring starts, and lambda tells you I'm trying to make this particular string that starts at I, has the length 2 power k. I want to make it to be a lambda good string. So your initial problem becomes it becomes 1. Your substring starts at the index 1, comma, log n, log to base 2n. Whatever was the initial length, you just find out what is 2 power k equal to that n. You find the k, okay? Find this guy k, and this is going to be your original problem. Now, if you analyze this thing, how many different subproblems exist? So for the first index, you can have nearly 10 power 5 different values from the constraints. The string length is up to n, and this represents where does my substring start. So a substring can start at any index. So let's say 10 power 5 values here. K can have at most 20 different values, at most, because it represents the length of the string. Length of the string can never be greater than 2 power 20, because initial length is only 10 power 5, right? So I'll say 20 values for that. For lambda, there are at most 26 different characters. So this is the maximum possible number of subproblems that exist, and this is well under 10 power 8. Okay, so here is a very easy to think of DP solution. dpik lambda equals to minimum of, convert the first half, convert the characters from the first half to to lambda. So what is the minimum cost to convert the first half? That means I comma k by 2. The substring that starts at index I and has this length, not k by 2, k minus 1. This is the exponent. So if the length was 2 power k, half will be 2 power k minus 1, right? This divided by 2. So you convert the first half. What is the cost to convert the first half characters to all to lambda, plus minimum cost to make the string that starts at some index I plus 2 power k. This is from where the second half starts, not 2 power k, 2 power k minus 1, because overall the string we are looking at is of size 2 power k. The first half is of size 2 power k minus 1. So the second half starts at the index I plus 2 power k minus 1. The size of this half is 2 power k minus 1 again, and you would like to change all these values here to lambda plus 1, right? Because first half all are lambda. I wanted an overall lambda good string, so first half I converted to lambdas. Second half I will convert it to a lambda plus 1 good string. Or the second option is that you do this. You convert the second half to all lambdas. Convert second half. Second half starts at I plus 2 power k minus 1. convert all the half starting here to lambdas. This half has a size of 2 power k minus 1 converted to lambdas, plus what is the minimum cost to convert the string starting at I, or the first half, okay, the first half to lambda plus 1 good string. So this is your DP solution. Now this solution will run well in the time limits, but the thing is that it will give you a memory limit exceeded error because you are using this DP array. Even though this DP array is not that huge, but the memory limit in the problem is small, so there is an observation to be made. The observation here is that no subproblem will ever repeat itself, and therefore you don't really need that DP array. And I'll give you a small proof why this observation is correct. So here's the idea. Initially you're solving for 1 comma k comma small a. Here k equals to log base 2n, and next you will be solving for the left half here, 1 comma k minus 1 comma small b, and here you will be solving for the right half, okay, 1 plus 2 power k comma k minus 1 comma small b. Now no subproblem from this left subtree will be common to the right subtree, because this left area will always represent the first n by 2 elements of your substring, whereas the right area will always represent the right side elements, the right side n by 2 elements, okay. So this left portion, no subproblem from this area will ever be seen in this right subtree, okay, because all these subproblems here will be representing a substring from the first n by 2 elements, whereas all the subproblems from the right subtree will be representing a subproblem in the right half. Therefore, none of these subproblems that appear in the left will ever be used in the right. Okay, so none of these will be ever used again in the right side. But can a left one be used again, like some subproblem Si here and Sj here, can they repeat themselves? No, even they cannot repeat themselves because of the same property. The same property that next time when you break it, no subproblem from this region will ever appear in this region, because this region is the first n by 4 elements, whereas this region represents the second n by 4 elements. So no subproblem repeats itself. And that is the basic idea here. You can prove it using principle of mathematical induction, I guess, but recursively it must be clear that if this left portion never appears here in this right portion, so you could go on breaking them and always prove this claim that okay, this left and right will be disjoint. So no subproblem ever repeats itself, so you don't even need the DP array. You can simply implement a recursive function and the problem is solved. I'll show you my code here. The first two got a memory limit exceeded because I thought I should have an extra array. बिल्कुल risk नहीं लेने का, DP लगा देते हैं. But anyway, so yeah. First of all, to find the cost of converting a particular region into a character of a particular type, so I want to convert a substring from some I to j. I want to convert all these characters from I to j into A's. I can count the number of A's in this region, and the remaining characters I will need to change. So that is the cost for converting all the characters from I to j into the character A. So to count the number of A's in this region, I could do a simple pre-processing in this frequency array, and this will be prefix the number of A's till the ith index, and then I could use okay, between I to j, number of A's seen till j minus number of A's seen till I minus 1, and that will be the number of A's in this region. This pre-processing is pretty simple. If you have any doubt, you can ask me in comments. This is the pre-processing that I'll initially do. Then this get count simply returns the number of the number of A's in the region in the substring that starts at I and has the length 2 power POW, and how many C's are in this region. Okay. Next is the solve function, which is quite easy. If length of the string is 2 power 0, that means there is just one character. You check if that character is equal to C. I wanted to make a C good string. If it is equal to C, then the cost is 0, otherwise cost is 1. You have to change it. Okay. Now there are two possibilities. This is the same recurrence that I discussed, and I've implemented it as it is. So hopefully guys this was helpful to you. Let me know in comments if you would like to see any other problem from this round. Thanks for watching. Make sure that you like, share and subscribe.